How about parallelism of two vectors? So I have a small diagram here. Can you see? These are two vectors, a blue one and a red one. And now the task is check whether those two vectors are parallel or not. So the first thing is always look. Of course, in this case, you already have given the picture. Sometimes you may not have been given the picture. Then you have to look at the directional vector, at the vector itself. And you have to think whether both vectors are parallel. And in most cases, you can already see it before you start to calculate. So my suggested two-step approach is first have a look and then calculate. So first you solve with your eyes, and then you solve on paper. And you really prove it. So it's not too complicated. Just have to keep in mind this is parallel, right? Two vectors. Can you see it? Two vectors. There's a parallel. But of course, for a math professor or for a math teacher, it's not enough to tell yes they're parallel or to solve with the eyes. You also have to solve on paper with a good calculation so that it's a true proof. I'm going to show you how it works in the following clip. How to check parallelism for two vectors. This is actually usually a quite easy task, and I will show you how it works. Given two vectors A and B, A is -1, -5, -6, and the other vector is B with 8, 40, and 48. And what means parallel? Parallel means, okay, in this case, this is a picture for 2 dimensions. In 3 dimensions you can imagine maybe black pen and red pen, and they're parallel in the area, in the sky, in the water, in the ground, but in the 3-dimensional world they are parallel, right? Something like this. But it's easier to draw and with 2 dimensions, so one could be A, one could be B, Y and X. So this is what we're looking for. So the thing is actually one vector is a multiple of the other. A multiple or a fraction, doesn't matter, but just a multiple with some sort of number, which is element R. But I will just show you in a second how it looks like. But just keep in mind, one, if both are parallel, one has to be a multiple of the other one. So the question we want to answer is, are those two vectors parallel? So first step, maybe make one first step, is have a look at it. So what I just said, one is a multiple of the other one. So I just look at one component, I look at the easiest component, 1. If you have a 1 anywhere, this is always the easiest component, or 0 can also be easiest component. But in this case we have a 1, and we see, okay, 8 is a multiple of -1, and the factor we need to use is -8. And then we can check for the second one, -8 times -1 is 8, -8 times -5 is 40, that's correct, okay. Up to this point they're parallel, and then we look, okay, third step, -6 times -8, and then we end up with 48. So just by having a look, we can say both vectors are parallel. Now maybe you're a little bit confused, but I'm going to show you actually the same things I just said with a calculation. So second step, calculate. And this is always a good thing. First have a look at it, solve it with your eyes, or come very close to the solution, and then you can calculate it. So by definition, as I said, if both vectors are parallel, one has to be a multiple of the other one. And this is the mathematical expression for it. So you can multiply one vector with some factor, and you end up with the other vector. So now we do it for our example. We have -1, -5, -6 times something, which we call R, some number, and we have 8. And this is important, this is not a vector, this is a number element R. And there we have 8, 40, 48, and if you're not sure about it, or if you have a parameter or something ugly, you can always do the safe way, which is take it apart and we write it down as 3 separate equations. So we have minus 1r equals 8, second equation. Minus 5r equals 40, third equation. Minus 6r equals 48. In this case, actually always, when those two vectors are parallel, all of these 3 equations have to be true at the same time. So we're looking for one and the same r in this case. So the way we're going to do it, we can solve it. In this case, it's very easy. We can just have a look at it, and we see r has to be minus 8. And then here we can just divide by minus 5, right? And then we end up with also r is minus 8, and third case r, of course, we already calculated it. 48 divided by minus 6, also we end up with minus 8. So we can conclude that r is minus 8. Therefore, vector a times minus 8, which is r, equals vector b. And therefore we see, okay, b is a multiple of a. We can also say a is a multiple of b, the other way around. Then we just have a fraction and not a nice number. And this means a and b, are parallel. And then it's already solved. So if you have to check for parallelism, just have a look at it, and you can check. Start with easy numbers like 1. Sometimes also 0 is very nice. If you have it here, if you would have a 0 here and here an 8, then you know, okay, whatever you multiply with 0, you end up with 0, but with 8 it's different. So 8 is not a multiple of 0. Then you could say they're not parallel. But in this case we have numbers. If you have numbers which are not 0, then you can just then you should look at the 1, because it's quite easy. 1 and 8. 1 times 8 is 8, and the sign is minus, so 1 times minus 8 is 8. And then you check for the other components, and then you can easily and quickly determine whether they are parallel or not. And if you know it, then you can just do the calculation, and then you have two solutions: one just by looking at it, one by really calculating it, and then you can be sure that you didn't make any mistake. So just keep the definition in mind. If both vectors are parallel, one is a multiple of the other one. And this is how it works. Thanks for watching. Practice makes perfect. Further exercises with solutions you can find on my website, which is www.worksheets.com.